Welcome to our series on calculus. In this, we have taken five very important past test questions on relative rate of change. I hope you will understand the concepts and enjoy the journey of learning with Anil Kumar. In case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. Our students are right there on the top, joining the best universities. The question here is related to spherical balloon rate of change of radius. Well, you'll see that the volume becomes surface area when you find the derivative at the end of this particular derivation. The question here is a spherical balloon is being filled with air at the rate of 3 meter cube per minute. Find the rate of increase in radius when the volume is 36 pi meter cube. Now, in all the related rate questions, we are actually relating two or more parameters and then differentiating it implicitly, normally with respect to time. So, that is the key while we are going to solve these questions. We should always begin with the basic formula. We're saying spherical balloon is being filled with air at a rate of 3 meter cube per minute. It means volume, right? So 3 meter cube gives you an idea. Meter cube is volume and per minute is time. Makes sense, right? So that is given to you as 3 meter cube per minute. So now we are looking at a sphere, as you know, and change of volume is what we are looking into. So we should know what is the formula for volume of a sphere, which is 4 by 3 pi r cube. You see how the things are related, right? Now, if I differentiate with respect to time, which normally we write like this, differentiate with respect to time, only t or time, then we get dv dt equals to d dt of 4 by 3 pi r cube. Now 4 by 3 pi is a constant. So therefore, we get 4 by 3 pi outside the bracket. R cube derivative with time will be 3r square. Now r is also a function of time. It is changing with time. So therefore, we need to still differentiate r with time. Correct? So it will be dr dt. You see, so we have dv dt in terms of dr dt. Perfect. Now, if you see, we are already given dv dt. Radius we need to find dr dt, right? One more information is given, which is find the rate of increase in radius when the volume is 36 pi meter cube. So at this instance, when the volume is 36 pi meter cube, what is the radius? This is what we need to figure out. So, okay, so the volume is 36 pi and it is related with radius 4 by 3 pi r cube. So cancel pi and pi. So r cube is equal to 36 times 3 divided by 4. Perfect. Right. 36 pi is the volume, 4 by 3 pi r cube. So we'll multiply 36 by 3 over 4. So we get r cube. Now, which is 9 times 3, 27. Or radius is cube root of 27, right? Which is 3. So we know the radius when we want to find rate of change of time. So now the alternative for you is you can rearrange the equation or just substitute the values given and then find drdt. So let's substitute the values. We know dv dt is equal to what? dv dt is given to you as rate of change of volume of 3 meter cube. So I'm writing 3 for that. And we got 4 by 3 pi. And this 3 also I'm cancelling now, correct? R square means 3 square. And only thing left is dr dt. Do you see that? So we have 3 by 4 pi, correct? And then this is 3 square, which is 1 over 9, equals to dr dt. Makes sense, correct? And this rate of change is when volume is equal to 36 pi. At this instance, radius is 3. So we have substituted those values. Perfect. And we are going to find what is dr dt now. So simplifying, 3 goes 3 more times. So we get our answer, which is dr dt equals to 1 over 12 pi. Radius being measured in meters and time in minutes. So it is very important to write down the units. Perfect. So I hope the concept is absolutely clear. A man is running over a bridge at a rate of 20 feet per second while a boat passes under the bridge below him at 10 feet per second. The boat courses in at right angles to the man and is 20 feet below it. How fast is the man and the boat separating 1 second later? Let us now try to understand a systematic way of answering such questions. Understand calculus with Anil Kumar. Now let's try to understand the question with the help of a sketch and then solve it. Assume that this is the bridge over which the person is running and has a height of 20 feet. The boat goes under the bridge at the right angle, so that is the path along which the boat is going. Person is right there above the bridge. Person is running right. So you can illustrate the situation making a rectangular prism, right? So at the instance when the boat goes under the person, that is the time which we are talking about. As you can see, this forms one side of rectangular prism, and that is the boat's position, right? So we have a rectangular prism right there. Separation between the two is the diagonal, the longest diagonal in the rectangle, correct? So that is the separation, let's call it S. We need to find the rate of separation. So let B be the boat position, A be the person's position. So, and let's say the height is h, which is 20 given to us. So I'll write 20 here. Now, since the speed of the person is 20 feet per second, then at any instance of given time, so distance which the person has moved will be how much? Will be this distance will be 20t. As far as the boat is concerned, it will go along the horizontal 10t at any instance of time t. Now these two form the two sides, the base of the rectangular prism, and from here we can find the relation s square equals to 20t whole square plus 10t whole square plus 20 square. So we can rewrite this as 400t square plus 100t square plus 400. Differentiating with time, we get 2s ds dt equals to 800t plus 2 times 100 is 200t, right? Plus that is 0. Now dividing by 2, we can write that ds dt is equal to, you can also divide by s, the separation between them, right? So I'll write 1 over s, and dividing by 2 all these numbers, basically it is 1000t, right? Gives me 500t. So we get an equation to find the rate of change of separation between the two. But what we need to find that at a particular instance of time, which is how fast is the man and the boat separation 1 second after. So what is the position when t is equal to 1 second, right? So when t is 1 second, we need to find s, the separation. Basically, at this time, s will be 20 square plus 10 square. You can find it from this equation, right? So let's take it to the next page, right, and then figure it out. So we have an equation that rate of change of separation is basically equal to 1 over s times 500t. Now for t equals to 1, we know that s square equals to 20 square plus, or we can use the other equation anyway, 10 square plus 20 square, right? So separation square is 400 plus 100 plus 400, which is 900. So s basically at t equals to 1 is square root of 900. We have to take positive value, which means 30. So we can substitute this value of 30 and find the rate of change of separation. So we get ds dt equals to 1 over 30 times 500 into t, which is also 1, correct? So you can simplify this and get the answer. So ds dt, the rate of separation, is equal to 50 by 3. Units will be feet per second. So I hope you have understood these steps. Let us now take next question on trough. Here is a very beautiful question based on related rate of change. We are going to analyze cross section of a trough, which is a right angle triangle. The question here is, a cross section of a trough is an isosceles right triangle, the base of the triangle being horizontal and uppermost. The trough is 10 meters long. Water is poured into the empty trough at a constant rate of 5 meter cube per second. Find the rate at which water level is rising after 9 seconds. Let us first sketch the diagram. So we have a right triangular isosceles trough whose length is given to us as 10 meters, right? So, and the water is being filled into it. So let's say this is the water being filled. So let us assume that the height is h. This is 10 meters. So dv dt, the rate at which water is being filled, is 5 meter cube per second. We are interested in finding the rate of change of height at 9 seconds. So we need to find what is dh dt at t equals to 9. So first thing is that we have to relate the volume in terms of height. How do we do that? Now, as some of you might know, that in a right angle triangle, if I drop from any vertex perpendicular to the hypotenuse, all the sides are equal in isosceles right angle triangle. Since see, this is 45 degrees, correct? So the two sides h and h will be equal. So basically, the base of this triangle is 2h and height is h. So area of triangle is what? So area of this triangle is basically equal to half base is 2h times h. Means h square is the area of the triangle. So we can now write down the volume expression, which will be area into length. So h square into 10 meters, right? So, or 10h square. So that becomes the volume of this particular trough. Now, in 9 seconds, what is the situation? How much water will be filled? Since the rate of filling the water is 5 meter cube per second, we know that the volume at t equals to 9 will be 5 into 9, right? Which is 45 meter cube. So that is the total volume. Now, if that is the total volume, then for this volume, what is going to be the height? You see that? That is how everything is connected. So let's find the height. We know that the volume is 45 and 10h square. So 45 divided by 10 square root will be the height. Correct. Or you can say square root of 4.5. So this is the height at t equals to 9 seconds. Is that clear to you? Okay, perfect. Now what do we need to find? We need to find the rate of change of height after 9 seconds, correct? We have all the parameters with us. So what we can do is that we have the volume expression, which is 10h squared. So let's do it here. Or on a fresh page we can do. Okay, so we have volume expression as 10h squared. We can differentiate with respect to time, correct? So that means we get dv dt equals to 20 h dh dt. So we can find what is dh dt now, right? So dh dt will be equal to 1 over 20h times dv dt. Perfect. We already calculated the value, so now we can find dh dt at t equals to 9 as 1 over 20. H value was square root of 4.5, right? And dv dt is given to us as 5. So let's use the calculator to find this value. It comes out to be square root 2 over 12. So height is in meters per second. So that is how we are going to solve this question. You get the idea. So when we are talking about application questions on related rates, there are so many parameters to be connected. As in this particular case, we first found the area of a right angle triangle as half times 2h times h square. Volume times 10 because the trough was 10 meter long, and then the derivative. And we also found after 9 seconds what will be the height, and then the rate of change of height at t equals to 9 seconds. So I hope all these steps are absolutely clear to you. You may go through this video once again and check many more videos from our playlist. That should help. Here we'll discuss how do we work when we have a conical pile of sand. Sand is being dropped on the ground at a steady rate of 9 pi centimeter cube per second and forms a conical pile whose height remains equal to half the diameter of the base. At what rate is the height increasing at 8-second mark? Let's try to visualize. So let's say sand is being dropped and it forms a pile like this, correct? So this is the sand pile. Now this is relatively simple question since we have already given relation between the radius and the height. Height is half the diameter means we are given that height at any instance is equal to diameter by 2 or the radius of the pile. So let's say if this is the height, right? And we're talking about this conical thing, and that is the radius. So the radius and height are related with the given condition to us. We are also given that sand is being dropped on the ground at a steady rate of 9 pi centimeter cube per second. It means the volume, right? So the volume is increasing with time at the rate of 9 pi centimeter cube per second. Now, we want to know at what rate is the height increasing at 8-second mark. So if t is equal to 8 second, what is going to be the volume? So then the volume will be 9 pi times 8, correct? So that is going to be the volume when we are really interested in finding all the parameters, at what rate the height is increasing. So we want to find the rate of change of height with time when t is equal to 8. So this is what we need to figure out. So I hope the situation is absolutely clear, right? Now let's write down the related formula. After all, what is volume? So volume is 1 by 3 pi r square h. Since r and h are same, we can rewrite this as volume is 1 by 3 pi h square h, which is volume is 1 by 3 pi h cube. So we have a formula in terms of h itself. And now we can differentiate with respect to time. Since height and radius both are increasing with time, the volume also. So that is implicit differentiation. Let's do it. So once we do that, we get dv dt equals to 1/3 h cube, so 3 times pi is a constant, h square dh dt. So we get dh dt, which we need to find. Now we also know that when t is equal to 8, at this time, what is height? That we should know, right? Because h square is there. So when the volume is 9 pi times 8, which is 72 pi, if that is the volume, and this is the formula for volume, we can find what height is, correct? So we'll use this. 9 pi 8 is 1 by 3 pi h cube, right? So 9 pi times 8, I'm writing 8 at present, not multiplying them, is equal to 1 by 3 pi h cube, right? So you can cancel pi and pi, see it becomes much simpler, and multiply by 3, so you get 27. into 8 is h cube. So cube root of this is what height is. Cube root of 27 is 3 and of 8 is 2. So we get height as 6. You get the idea. So we know the height. We have this particular formula right there that dv dt is equals to one third will cancel pi h squared dh dt. Is that clear to you? We can substitute height equals to h and find dh dt. Correct. So we'll do all the calculations in the next page. Correct. So basically what we did was that we found that the volume was one third pi h cube since r equals to h, right? And we wrote dv dt as one third into 3 will be just 1 pi h square dh dt. And now we are going to substitute the given values. dv dt, volume rate of change is 9 pi. Right? So we are going to write 9 pi. H we figured out is 6 square. And we need to find dh dt. Makes sense, right? So if you derive as we have done, you will clearly understand what is going on and how do we solve such questions related to related rate of change. And now it's a question of reorganizing and finding dh dt. So dh dt. Remember the instances when t is 8, correct? Pi and pi you can cancel. And what you get is 9 over 6 square, which is 36. And 9 goes 4 times, so 1 over 4. So that is the change in height, unit being centimeters per second. Do you see that? So the change in height at the instance when time is 8 is 1/4 of a centimeter per second. Perfect. So I hope you have understood the whole strategy. Calculus with Anil Kumar. Let us now master the strategies for solving related rate of change application problems. In this video, we are discussing about a ladder and trying to find the sliding rate related with the dimensions of the ladder. The question here is a ladder 25-meter long is leaning against a wall. If the bottom of the ladder slides away from the wall at a rate of 3 meters per second, how fast is the top sliding down the wall when the bottom of the ladder is 15 meters from the wall? First step always is to sketch a diagram. So let's say that is the ground and this is the wall. The ladder is shown, which is given to us as 25-meter long. And the instance is when the bottom is 15 meter away from the base of the wall. If the bottom of the ladder is sliding away from the wall, right, in this direction, then let's call this as x and wall as y. Now both are functions of time as they are sliding with time, so we can always write this as x of t and y of t. But at the given instance, when 25 is the length, what is the value of the y value, right? So at this instance, we can find 25 square is basically equal to 15 square plus, let's call this as y square. Now in this particular case, it is 25 square minus 15 square square root, which is y. Now that is equal to 20. So the value of y is basically 20 at the instance we are trying to calculate the rate of change. Now in this particular case, we are given that the x value changes with the rate of 3 meters per second. The ladder slides away from the wall at the rate of 3 meters per second. So that means we are given that dx dt is 3 meters per second. How fast is the top sliding down the wall when the bottom is 15 meters away? So we want to find what is dy dt when the value of x is 15. You get the whole idea. This is what we need to find. So in the given situation, we need to first write down how these parameters are related. 25 is constant, so we know that xt square, the horizontal distance, plus yt square should be equal to 25 square at any instance of time. Now at this stage, if I differentiate with respect to time, in that case I get 2 times x, right, dx dt plus 2 times y dy dt equals to constant derivative is 0. So from here we can find the value of dy dt, right? Isolating dy dt, you can cancel out 2's, right? 2 will cancel. So dy dt is equal to minus x dx dt. So this is y times, I can divide x by y. So I've rearranged the equation to write it dy dt is this. What we need to find is when x is 15, at that time dx dt is 3 meters per second. We have to find what is dy dt. So we can substitute the values dy dt when x is 15. At that time we get minus x is 15. The value of y we calculate initially as 20 and dx dt as 3. So that gives you 15. You can divide, and then dividing by 5, 5 times 3, 5 times 4, we get minus 9 by 4. Units being meters per second. Now negative means it is sliding downwards, correct? So how fast is the top of the top sliding downwards? It is sliding at the rate of 9 by 4 meters per second. Is that clear to you? Perfect. So the steps involved are write down the initial given conditions and then write an equation, differentiate with respect to time, substitute the values and get the answer. So I hope that is absolutely clear. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.